design engineering, and then I got into operations. So I kind of know where you guys are from. I understand where you're from and some of your questions. I didn't design this collapsible stabilizer because I'm in operations now. I was just chosen to be the caretaker of it.
Voluntold?
Yeah. As you guys know, we came up here in December right before Christmas. The next thing I know, I was on a plane up here going to the rig. And had a wonderful time up there. ExxonMobil came to Weatherford, and I think it was 3 or 4 other service providers, and said that we have a concept that we want you guys to give you your best design on. So George, y'all know George? Jarvis? And I think it was Elena? She's not in there anymore, but anyway, they came up with the concept. Okay. And this patent on this collapsible stabilizer actually belongs to ExxonMobil. No? It's yours. Okay. It's not ours. We just designed it for you guys. Okay? Now we have the right to rent it as well, but you guys have a lucrative contract with us for the next 3 years. And so we won the design work. And we started building it. Next thing you know, it was done. We're here.
How long was that cycle?
You know, it had been right about 6 to 8 months.
Oh, wow.
I mean, it was the fastest I've ever seen anybody. I mean, when I got involved in it, I mean, it was like 3 months, you know, from the time I got involved to till today. And so it was real quick. I couldn't believe how fast we reacted. It was very, you know what? I guess when somebody's paying the bill, you'll do anything you can. You know, and that's what Exxon was doing. They were paying for the bill. So we met every deadline that Exxon provided so that they could get this paid off by the end of the year. And it really turned out really good. The test was fantastic out there, and I'll show you guys this. But just a little history on why Weatherford's even involved in this at all. Okay, so we're gonna make this very relaxed. If you guys have anything that you guys want to discuss or talk about, please stop me. And I'll try to answer it. If I don't know the answer, I'll definitely try to do it for you. But this is the, what Exxon did, they went out to all their field locations, and they said, I want to know where you get stuck. And I want to know how many times you get stuck. And what they developed, or what the concept was, is they got stuck in the utmost stabilizer most of the time. Not all the time, but most of the time. So they came up with the idea, we want a stabilizer that will collapse. We don't care if it only works once. We want it to collapse to try to get out of the hole. Our goal is to get out of the hole. They don't care for it to open, close, open, close. They just says, we want it to close, we want to see if we can get ourselves free. Because they're tired of losing expensive EHAs because of being stuck above the stabilizer. Okay? So, what the stabilizer does is it prevents bottom hole cylinders from sticking in a horizontal extended reach well. Okay? We didn't do it in a horizontal extended reach well, which is fine, because all we wanted to see is how rugged this tool was. Okay? There was some discussion at the rig site about putting it in their intermediate section, and I was all for it. I wasn't trying to push it, but as you know, we talked about it. We weren't able to provide the smaller blades that we were needing. Right?
Yeah. So, just for Sarah, probably has been involved, or even Jeff. We got hung up. We used a stabilizer change under intermediate BHA. We went from 10 3/4 to 11 3/4, and the theory behind that was it's going to give us more consistent build rates. But what we found is we were getting hung up, potentially on stringers. But we guessed that we were getting hung up, and they were unable to get our build rates because we couldn't transfer anything down. So we went back to the 10 3/4 stabilizer. So this was a 12 1/8. So we were concerned with putting in the intermediate. We'd have the same situation we did with 11 3/4. So we asked them, is there any way we can put smaller pads on it? But the turnaround time and everything else, we were going to catch it probably on 2 or 3.
3 or 4.
Yeah, so it wasn't worth the effort. We still were able to provide some of the data. I think you wanted like 500 hours, but how many hours I guess would that have been? 14 wells?
Yeah, so we didn't get it, we only got
4
about
hours.
21 hours.
Yeah.
You know, cause these holes are real fast. I mean, I was looking at it and I go, 650 meters, what the hell was that related to? I mean, that's going down fast.
Jumping speeds.
I don't even think your bit even touching the hole, to be honest with you, I think you're just jetting, seriously. But, you know, I'm used to 1 meter an hour,
Yeah.
not 300.
Different world up here.
Yeah, y'all do. So, and to be honest with you, we didn't design this stabilizer for this area. Danny and George and Paul, they just wanted to get some runs in it. They knew that this was not, and we probably won't ever see this full up there again, but we might, you know, it just depends. So the application is to serve as the utmost stabilizer in the VHA. Right now, I think you guys only are running one stabilizer, you know, in the VHA. So you don't even have a second one. Okay. And what we're doing is preventing VHA sticking during drilling or retrieval operations in horizontal extended reach wells. And then we're clean cutting from the bore. After the stabilizers collapse, 3 jets open up and actually help you wash out. Okay. So, some of the features, the simple design of the collapsible stabilizer assures reliable performance. Collapsible stabilizer quickens VHA, okay, and helps avoid lost in hold. All right, and then the hydraulic force pushes the locks of the stabilizer blocks open against the body to prevent the tool stability and minimize vibration. And we felt this at the surface. I asked several of the drillers while we were drilling. We had 3 different drillers, Mike, Todd, and Bryce. Okay, and every single one of them says the vibration is left. Okay, so I'm not saying our tool did this, just having a second stabilizer up there probably did that.
Yeah, that's probably gonna be one of our lessons learned, so we need to evaluate that. So what we're talking about doing is doing some lap swaddling, like I done in technical, and compare how we have single stabilizer versus 2. And I think we found a more efficient way to drill. It's even seen it on performance as well.
And this is a lesson learned. This is not me telling you guys what to do. It's just an observation. I'm not asking you guys to do anything. It's just an observation that I saw and I asked.
I'm just gonna verify with the data, but going forward, we'll probably have a second stabilizer on all the surface holes again.
I would say, yeah.
Okay, and then like I said, the nozzles are able to hold clean after the collapses. Matter of fact, I'm gonna leave this presentation with Keith, so you guys don't have to take notes unless you just really want to.
It's how I remember stuff.
That's fine, but I am giving this to you guys, so you guys can have. All right. All right, this is the engineering specification sheet that you guys got right there. Has the body, the blades are 12 1/8. Do y'all understand inches or do you?
Oh, yeah.
Yeah.
Okay, thank you.
We get
Okay.
more easy to go back and forth probably than you guys are used to.
You know, when I was in, I guess it was in junior high, I guess the United States told Canada we were gonna go Mecca, and then we didn't. Y'all did, but we didn't. And that was, yeah. But anyway, so 12 1/8 was the OD of the stabilizer blade. The body, okay, is 10 1/4. That's a, oops, sorry. That's this area right here. The fishing net is 8 1/4. Okay, and then the internal diameter is full bore, 2.81. So we didn't have anything, this was not the restriction in the VHA. Okay? We have shear pins on the bottom to that shear out, and we could shear them anywhere from 20,000 PSI to 60,000 PSI. And when we were talking to Keith and Danny, there was a discussion between the two. Danny wanted 60, Keith wanted 20. But Danny won and we put it to okay, so you have the specifications there. This is the components. You have a upper sleeve up here, and I'm just showing you what the components are. We actually got a video, a Pro E video, that will show the movements that you guys will really enjoy.
Nice.
We have a stabilizer pads. We have 3 of them, okay? And then we have a mandrel that holds the stabilizer pads in. we have a pin that holds them in place, and a pin have a special, locking mechanism to keep them in place from the body. There is no way that pin is going to break and fall out. Okay, just, there's no way it can happen. The lower sleeve, just tapes, it's just basically a piston, really. It has a seal right here, and then it also has a seal on the ODs, and it keeps those two mandrels locked in place. That is, ease in a disassembly of the tool, okay? And then we have what we call, positive unefficient indicator, which is basically a mandrel tube, but you can see that slot right here. When it moves down, it will be in line with the nozzles, and that's what allows the mud to flow through. And then we have the shear pin housing right here, okay? And we'll get in more into detail on this. All right, this is a Pro E CAD video of this. We're gonna stop and pause it, but I'm gonna show it to you first, and then we can stop and pause it. I love Pro E. I don't know if y'all use Pro E here.
Well, it's out.
It's a 3D animation that you can sit in and put a video to it, you know, full scale. This is fully stretched open, as you can see. There's the hole, and it's just showing you all the points. There's a shear pin right there. Like I said, I'll run it and then we'll go back to it. But here you have a restriction in your weld. The stabilizers are now stuck. You pull on it, shear pin is shear, and it closes up. Very, very simple. Okay? Oops. All right, my mouse covered. Now I'm gonna pause it here.
So the second that you hit a restriction, it closes them,
Yes,
and they'll never come back up.
it'll never come back up. You're right.
So you don't really wanna read at all. Well, yeah.
Is it? Oops, sorry. I'll start all over again, I'm sorry. Hit the wrong button. There's that sleeve, it just has ODs, ID seals to keep the mud from going around it, okay? Right here is your shear pins, okay? And it's in line with these mandrels, so when you pull on it, you're gonna shear those shear pins. And those shear pins, the bottom half will stay retained in this housing, and the top piece will stay up there too, so they'll never pop out either.
Okay.
We have 12 holes that we can put in there, and I think they're 3,565 pounds to shear them. So I mean, so we could pull over 60,000 and we'll shear them up to 60,000. I think we got 11 on these, which is right at 60,000. Okay, see right now, if you'll see, we're stuck on the top of the stabilizers. And what happens is that when you're stuck here, all your forces go down into this mandrel, okay? And that mandrel will push into it. And as soon as those shear pins shear, this port will go underneath your nozzles and it'll open up. So, I mean, I wish I would have thought about this. This is such a simple design. There's really nothing to it. You know, it's just
Pretty simple, but.
it's very, very simple. So, so when it shears, the stabilizer blades collapse. They'll run up a ramp on the back side of it to keep it in a closed position. And because now you've got this jet porting out, now you don't have a pump open force. So you'll never be able to get that tool closed. Because now you've got your mud going through your port coming out. And you don't have any piston area, you don't have a pump open force. Okay? before I go there, let me just show you our actual pull test. You guys will love that too. What we did is we put it in our, we went to our directional drilling surfaces and we put it into a concrete block. And what we did was we had a 8.5 inch hole that we opened up to 12 1/4. We actually drilled into this concrete block. And we, after we drilled the hole, then we moved it in and out, just cycled it back and forth to simulate horizontal drilling.
How many times you cycle it?
Say again?
How many times you cycle it, or for how long?
You know, I don't know exactly how long, I mean, how many cycles we did.
Yeah, or
But
just
we
kind of
did
time
10
frame.
hours
Okay.
of solid back and forth, back and forth. And these, PVC bits on the stabilizer pads are just something that we took off of our, reamer that we have. Well, there's better pads out there, you know, for wear and tear, but this is just something we wanted to try. Here we are, we're drilling. All this is captured in that enclosed system, so we don't have to worry about spill.
Is this in Houston?
Yeah, this is in Houston. And, so here we are, we're just cycling it back and forth, we're pulling it out now just to see the conditions, see what kind of wear we're having. Okay, let me stop it right here. Okay. Let me back up a little bit. All right, what we did now is after we cycled it and we stroked it for these 10 hours, what we did was we took it over to a horizontal press. And we have a 11 3/4, 65-pound casing that we made a fixture, welded it on to this pull test. So we butted up a stabilizer pad up to the casing so that we could pull with it. Now we had this sheared at 20,000, I believe. So, so we had to pull 20,000 to shear to get it through. So what you'll see here is that the pads are up against the casing wall. We pull it, come on in.
I
So
don't
we-
remember, we swapped.
So what we do is we'll pull it,
That's an hour fight to swap these rooms with those two, sorry.
no problem. We'll pull it, the tool will shear, the pads will go inside the casing and the jets will open up, okay? All right, now this is the up end down here, we're pulling this way, so there you go, it opens up, and then it goes up underneath and goes inside.
Well, try it again. Cool.
And as you can see, we weren't pulling straight. We were actually cocked a little bit, but it still lined itself up and it actually, went on in. We could have gone all the way in, but we just stopped right there. That's George telling us how to do things. There he is again. And that was the engineer, Wade. He's the one that engineered it. So. Anyway, I figured you guys would enjoy that.
So is this the first place that that has run it?
Say again?
Or is this the first time it was ever run?
This is the first time it was ever run. We only have two existing, and you two had it up there at the Kita 32 rig.
No, you always say you don't run show number one.
That's no longer true.
Okay, so here was the rig test objective. This is why we were up here. To verify the stabilizer readiness by rotating and reciprocating in a 311 hole. Okay, observe and monitor the collapsible stabilizer after each run. So I had to get up at 7 o'clock in the morning, midnight, 3 o'clock in the morning, 4 o'clock in the afternoon. I didn't have a schedule.
Sounds like Corey.
And then record the drilling parameters. All right, this was the BHA that we had, your current BHA. The only difference was that we put the stabilizer on top of the non-magnetic collars, and then we put the heavy weight and then the jar assembly on up. Okay, so just so that you guys knew where we put it. Now, we first were gonna put it in between the two non-mags, but then Halliburton said, no, that will screw up everything, so we put it up on the other, which makes sense. All right, here we have 311. We were drilling to 237 meters. Our hole angle is anywhere from 0 to 18.3. Okay, RPMs were 30 to 80. Most of the time it was right at 60. That would be your average. Weight on bit, it was roughly around 5 to 6 most of the time on the average.
Well, we got up a little higher near the end there.
Yeah, you did. You got up to 9.
The average though, yeah, we're around 6.
5 to 6, so it's your average. Flow rate stayed the same. Standby pressure, it moved up there pretty good. And then the rate of penetration, man, that was 0 to 500. I mean, that was just.
You're gonna have fun explaining that one.
I know.
99 feet? Yeah.
Well, do you know what? I had to go to the driller and I had to ask him, I said, am I reading this right? Is this really 500 meters per hour? He goes, yeah. And I didn't know it, but y'all have a limiter on that rig that will keep it from going any faster.
So yeah, we were actually up at 630.
I saw it one time 650,
Yeah.
but I wasn't gonna put it on here. I'm sorry, I'm not gonna put it on there.
We were told that, we went back to before, they used to limit how fast your drawers would spool out. And we had another Akita rig, and 32 was always set around what they said was 500, or 570 I think was the number. And then 29 was only at 250. So when the rigs were in the same field, they'd be like, well, this rig can go this fast, this rig can go this fast, and eventually.
They're like twins.
Yeah, eventually Akita had to change that limiter. And then I've heard 570 was the number, but then as we're clipping up at 650, I'm like, well, what happened there? So what's the real number? No safety factor.
Yeah, because when that very first well we did was 500. And I sent back a report back to Houston saying we're going 500 meters per hour. You talk about the phone ringing.
Yep.
That they were, not from ExxonMobil, from our people. Yeah, they couldn't believe it. I mean, but anyway. All right, here are the 14 wells that we had, okay? And basically, all I did was record the hole size and measure that, the angle, the RPMs, everything that we were just discussing. And as you can see, and then first run, second run, and then how many hours. It was actually drilling and circulating. It wasn't the actual hours that it went in the well and came back out. This is actually from the motor report. Okay, with Halliburton provided.
No,
Nice. I was
Oh my
hoping those would
gosh.
be helpful.
right here. You can just leave them on the table here.
Well, if you're gonna leave those cookies, you're gonna have to take another spice with you.
You don't bring those back?
Oh, wow. How was the map so far?
So to be honest with you, I think we only had one well that we had any kind of issues with the rig.
17.
I think we had a pump that go bad.
That liner.
But other than that, I mean, everything was really smooth. I was totally impressed how well the rig was running and how well. Our very second run was a little bit longer because we had Todd just learning how to use the top drive. I mean, I'm up here going, okay, you don't know how to run the top drive. Why am I up here? But he did great. He did fantastic. I mean, after the second hitch, he was doing great.
Yeah,
He built up a lot of
we're
confidence.
watching.
I know you guys were.
I can tell who's drilling just by looking at that block height.
You know, Mike was very efficient. And so, Bryce was good. I mean, they were all good.
Which one's split?
Razzle.
Mike is the real tall, skinny one. From,
Oh, think so.
Nova Scotia?
East Coast.
Yeah.
Nova Scotia?
Mhm.
Bryce,
He's a-
Bryce has been drilling on 32 since we got it back in 2012.
He's a local guy, right? Right, yeah.
He's from Alberta, I'm pretty sure.
I think he said he lived in Cold Lake and.
Oh, really? Maybe he does now.
Okay, here's some of the pictures, running in. This is the very first day. And here you see the ice crystals on the tool, so that's pretty cool.
How'd you like the cold?
That's okay, I didn't mind it. These are just the first runs going in.
Nice time of day to take that picture of the first one, actually.
What's that?
So it looks pretty good with the first picture.
Yeah, it is nice.
Yeah, I love
Fun
that
just
picture.
going down.
If you notice, it's my, that I put on my background as my presentation. I just faded it out, but, so this was just first run. That fourth one was somewhere around the third or fourth run, running it in. Here's pulling out a hole, which I thought was very interesting. This was, the mud ring on the very first well,
Okay.
okay? This was about the third well, and so it had a really nice mud ring. And then, somewhere around the seventh or eighth well, and then this was one of the 8